So let's jump directly to the agenda of the demo. So in this demo we will discuss monolithic architecture, monolithic architecture of software development. Then we will see microservices architecture, microservices architecture. Then we will discuss about frameworks. Then we will go ahead with Spring framework. We will discuss Spring framework, and lastly we will discuss deeply about Spring Boot, and finally we will create our first Spring Boot app. So this is our agenda of this demo. So let's start directly with our first topic. Before that, I would like to discuss some things with you. Here we will discuss with monolithic architecture. We will discuss what is monolithic architecture and the key characteristics of monolithic architecture, and advantage, disadvantage, and when we should go for monolithic architecture. So that would be our flow of discussions. And then in microservices we will discuss same things: what is microservices, key characteristics of microservices, advantage of microservices, disadvantage of microservices, and when should we go for microservices architecture. So for these two architectures we will discuss the same things. And then for regarding frameworks, we will discuss what is framework, what is meant by framework in IT, in programming, what is meant by framework. Then we will discuss key aspects of frameworks. Then we will see different examples available in frameworks, means such as a Django framework in Python, then Spring Boot or Spring framework in Spring, Hibernate framework in Java. So we will discuss all those examples related to frameworks, why it is needed, how it helps developer to do lot of things without any bottleneck, how it removes lot of bottlenecks and boilerplate code, how it simplifies developers work by giving lot of features and avoiding developers to develop from scratch. Then we will discuss about Spring, what is Spring, why it is came in market, when it started developing Spring project. Then different Spring modules we will discuss, like Spring EOP, Spring Data, then Spring Security, Spring MVC, such Spring Core. We will discuss each and every overview of each and every module. Then we will go directly with Spring Boot, and we will see how Spring Boot is helping developer to develop any enterprise grade application, production ready application with very productivity and with speed, and allowing developer to develop important business logic rather than looking after other external things here and there. So it allows developers to focus on major functionality, and all other things like deployment, then jar creations, auto configuration, server management, all those things are Spring Boot will take care of each and everything. So after that we will create our first Spring Boot app, and we will demonstrate it practically how to create Spring Boot app. We can do it by IDE features, or we can go directly with Spring.io initializer, and we will create that dependency. I mean, we will add all the important and required dependencies according to our project. So we will discuss each and everything step by step. So let's dive into our first architecture, first topic, that is monolithic architecture. So monolithic architecture, here we will go ahead with what is monolithic architecture. See guys, monolithic architecture is nothing but a uh, in a layman term we can say it as all code in one single file, in layman term. Okay, we can see monolithic architecture in software development, where whole application is developed in one single file. All the logic such as the business logic or data logic, data access logic is developed in one single file. So it will have unified code base. Okay, and it is an indivisible unit because each and every logic is developed in one single file, so encompassing all the features in one single file such as user interface, UI, and then business logic, and then data access layers. All things are developed in one single file. So it is very old architecture, and it is used by developers right now also, because it depends on the context of your application when to use particular application system architecture. It depends on your type of project and the need of project. So it is not completely depreciated. It is used by a lot of developers in IT industry, but it depends on context of the project, it depends on context of the app, and when to use a particular architecture. It has some advantage and disadvantage also. So first we have discussed what is monolithic architecture. I would like to tell you that this is all in one structure. Okay, so it is really helpful. It is really helpful for initial development and deployment of the application without any delay and without any complexity. But it is really fast for initial development and deployment. But when we want to scale particular application, or after deployment, if we want to maintain that project in long term and we want to scale that project, then it becomes difficult, because it will create a lot of dependency on each other, and it will have a lot of complexity and maintenance errors, because each and every component is depend on other component, and if we change any particular component, then it will create a problem in other component, because all the components are tightly coupled with each other. So we cannot change one component without changing other component. So there is less independency, less independent features in my monolithic architecture. So what we'll do, we will talk about its key characteristics. Okay, I would like to add its key characteristics. Key characteristics. See, first and most important is unified code base. It will have unified code base, means each and every functionality will be developed in same file, one file, or uniform code base. Okay, so every function will have unified code base. Unified code base with not only the code that is residing in one file, but it will have same one language, one repository, and one code base. So we cannot use different tech stack to develop such applications. We have to use one single language only, and we have to use one repo for every features. So this is first feature, key characteristics. Then second characteristics is tightly coupled features. See, all the features in monolithic architecture is tightly coupled, so that it is really they are really interconnected and interdependent on each other. So if we change any one feature, then we have to change all other features, because according to first change, we need to follow same changes in each and every features. So it becomes difficult to sometimes it become difficult to do all those things, and it will create errors in our project, because it is difficult to change one feature without changing other feature. Then third feature is that single deployment. We do not need to deploy each and every application separately, because this is one application. So once we deploy it, it becomes working application. So we do not need to worry about lot of configurations, and it is very easily and speedily possible to deploy such applications. And fourth feature is all or nothing scaling. It simply means that if you want to scale particular application, then you need to add or change each and every feature. Otherwise you cannot change single feature, because it will create error in each and every other features. So if you want to scale particular feature, you have to change each and every feature according to that changes. So it becomes difficult to maintain such applications, but it is really used in small projects where less number of engineers are there and less resources are available. Now we will talk about the simplicity. We will talk about the advantage of monolithic architecture. The only advantage is that it is simple to develop such applications, and it is easy and very speedy to deploy such applications. But there are lot of disadvantages regarding these applications. We will go one by one. It has a complexity and maintenance problem, because when we add all the features in one single file or one single project, it becomes really complex to identify each and every logic, and we need to have compartment for each and every logic. But if we add each and every code in one single file, it is really difficult to maintain that code, and code readability is also not achieved. So it becomes difficult to follow such applications and maintain such application, and it increase complexity over the time when our application is enhancing, or we are creating more complex application. Another challenge is that it is difficult to scale such applications, because scaling is not easy. We cannot change any one feature, we cannot change or scale one feature that is required, we required. If we want to change or scale any feature, then we need to change each and every functionality. So it is not that easy to scale such applications. Third challenge is that tech adoption hurdles. See, if we want to change particular technology related to anything or any feature, we cannot change it in silos. So it is difficult to adapt such products to new technology, because we have to change each and every feature according to new technology. And fourth is that reliability risk. We cannot rely on one application monolithic architecture, because if there is problem in one feature, our complete application will die, or it will not work, and it will create problem to run other features also. So it is difficult to rely on such applications when there is applications who those requires scalability, maintainability, and they are evolving applications every now and then. Right now, final point regarding monolithic architecture, we will discuss when to use this application. Okay, application structure. We should use this application software architecture for small applications and small teams. And second, we should use this architecture for applications with limited updation, means that app is not evolving every now and then, and if we want to build such app, we just need to build it once and then we will deploy it, and it will not evolve daily or every now and then. It is just a simple static application. We just need to develop once and deploy once. So at that scenario we can go ahead with monolithic architecture. So guys, I would like to show you one diagram related to monolithic architecture. Let's see. uh, we can directly go ahead with Google monolithic architecture diagrams. See, we will take this example. See guys, here we are having 3 clients and they are sending their request to our API resource, API endpoints. But there is one load balancer who is managing this request and sending this request to appropriate services, appropriate applications. So here is our application, which is having all the application developed in one single file or one single project. We can see here we have catalog service, discount service, order service. This e-commerce application is developed in one single service and only one database is available for whole application. So this is monolithic architecture where all the code is deployed in one single application and it becomes one database is available for each and everything. So if one service gets damaged or one feature gets damaged, all other functionality can be damaged, or it becomes difficult to run each and every functionality. So this is a monolithic architecture for e-commerce website. Now we will go ahead with our second architecture, that is microservices architecture. Microservices architecture gives improved version of monolithic architecture. Here we develop each and every feature in one small project. Okay, each and every service or each and every feature will be developed as one microservice, and which will run independently, which will have its own process ID. Sorry, I forgot to tell you that in monolithic architecture each and every application will be run in one single process ID. Means whole application will be run as a one process ID, one process, and it will share same memory, and which is difficult to manage resources, and it will become limited resources also. So we will have microservices architecture where each and every services will run on its own process ID. It will have its own memory and it will communicate with each other with lightweight communication tools such as REST API, REST standards, standards to communicate with each other. So it becomes really easy to deploy such microservices, and it becomes loosely coupled architecture, because each and every service can run independently without need of each other, and if any service gets damaged, we can solve that service, but other services will not be affected, they will run independently. So it becomes fault tolerance application development, because of one service it will not affect other services. By definition, we can call microservices as a small, independent and loosely coupled services. Small means for each and every feature we will develop one microservices. Independent means it will be independent, it will not depend on other features or other microservices. And loosely coupled means they will not have any correlation with each other regarding functionality. They will have their own resources such as their own memory, then process ID. So they will not be they will be loosely coupled, and they will not have interdependence on each other for execution. They will have their own database, their own technology stack, their own server also. So they will communicate with each other through lightweight protocols, and they are independently deployable and scalable also. Means if we have 4 to 5 microservices, and if we want to deploy each and every one, we can deploy independently. Okay, we do not need to wait for one another for deployment. Second, we will have if we want to develop, scale one microservices from among all of the 5, then it is easily possible, because we do not need to add functionality in each and every microservices. If we want one microservices to be scaled, we can do it very easily. So that is what we mean the loosely coupled architecture means. Now we will discuss the key characteristics of microservice architecture. First, key characteristics. Key characteristics of microservices. First, it will have small independent services. That we have already discussed. Okay. Then it will support independent deployment. If we have 10 services and if we develop four of them, we can deploy it. We do not need to wait for other services. Independent deployment. Then technology diversity. I will elaborate this point in detail. See, we can use any technology stack for each and every microservices. Means if we use one database, that is Oracle database for one microservices, we can use MySQL for other service, and we can use MongoDB for third service. So we do not need to depend on one particular language. We can use different languages also to develop particular microservice. Means if we develop one microservice in Java, we can develop second microservice in Python, and we can develop third microservice in .NET. It is really possible. It will not depend on technology, and we can use diverse technology for diverse requirement. If we want to use relational database for particular type of data, we can use relational database. If we want NoSQL database for particular type of data storage, we can go ahead with MongoDB or no structured database. So it is really a good feature to have, because we do not need to depend on particular technology stack and different programming language, DBs and tech stacks can be used. The fourth feature can be decentralized data access. See, each and every microservices will have its own database. So it is really decentralized in nature. Each and every microservices will have its own database, so it will store its own data into same database. So it will not depend on each other for data storage, and it becomes really easy to access and store such a data related to particular microservice. The fifth important feature regarding microservices is that communication via APIs. Communication via APIs. See, microservices are developed for each and every feature, but they need to communicate with each other. So they use lightweight protocols like REST APIs or message brokers like Kafka. Okay, to communicate with each other and coordinate with each other. So this communication is very important between microservices to keep it functioning for long period of time and keep it functioning rightly. The last feature is it is organized by business capacity. It simply means that each and every microservices will have one business functionality in it, and we will not combine it with each other. one microservices, one feature will have one microservice, so that if that microservices service get any problem, then it will not affect other business functionality. So that's it, guys. I would like to tell you about the positive and negative factors of microservice architecture. So positive features, its agility and faster development. It allows faster software development, as we can develop independently and we do not need to depend on any other. Second feature can be scalability and elasticity. Scalability and elasticity. See, we can scale such applications where we have microservices architecture, because each and every microservices is independent, and if we want to develop or scale any particular microservices, it is possible to do without touching any other microservices. So these are independent and loosely coupled, so that we can develop, scale any one microservices for whatever we want. Third advantage of microservices is that improved fault isolation. It simply means that if one service fails, it will not break down whole application. Our application will run independently, and we will solve that one service problem very easily, because our application will function and it will not collapse completely. Fourth advantage of microservices can be team autonomy. This is very important feature to achieve productivity, because each and every team or each and every member can develop his assigned microservices without waiting for other team or other developer for its input. Each and every feature will have one microservice, and each and every feature or each and every microservice will be developed by one small number of team, or 2 or 3 number of people of that team will include 2 or 3 people only, or otherwise we will have one person team where one person will develop that one particular feature. So they will work independently without waiting for each other's approval, and they do not need to coordinate with each other for each and everything. They can easily move fast and develop such a functionality without anyone's waiting time and responsiveness. And last but not the least, we can add advantage, that is resilience to fail. Resilience to failure. It simply means that if one microservice will fail, others will run. It will not be get affected. It will not affect each and every feature of the application. So they are resilient to fail, because whole application will run without that one feature. Now I would like to discuss negative points about microservice architecture. The first and foremost point is it increases the complexity of application development. It increases complexity as compared to monolithic architecture, because we have to communicate with each and every microservice. We have to containerize all those microservices, and we have to use different lot of tools to communicate with each other, and for each and every feature we need to create one different project. We need to have more resources, because each and every microservice will run on separate process ID. It will have its own memory, so it is really a complex task. So we need more resources to have such architecture. Second, second problem can be inter-service communication. As I have already discussed, it is really resource intensive task because we need resources to communicate with each and every microservices in between. It requires network, it requires security, it requires data consistency. So all those resources are very complicated and not easily available. It will be costly affair. The third drawback can be operational overhead. Operational overhead. Because we need to run microservices, we need different tools and techniques and new technologies to coordinate each and every microservices and to orchestration of each and every microservices. The tools like Kubernetes needed to manage deployment and have coordination with each and every thing. So it becomes operational overhead also and cost overhead also for the company resources. The fourth drawback can be debugging of the system. See, we have n number of microservices, so it becomes difficult to find the root cause of the any problem, because we can't easily find out which microservices is causing problem and due to which where that fault is lies. So it is difficult to get to the root cause of the particular problem. So we have discussed about plus and negative, positive and negative points regarding microservices architecture. Now I would like to discuss when to use microservice architecture. When to use. See, most important requirement to use microservices architecture is for complex and evolving application. Means any app that is evolving day by day, every now and then we should use microservices architecture for such app. And secondly, any complex architecture, complex applications that is having lot of features, and those features are real-time features and they are changing depending on context. So we need to develop such architecture, such applications based on microservices architecture. Secondly, whenever we want to independently deploy all the services, we want independency between them. We do not want any dependency and we do not want any waiting time for each and every microservices to develop. Then we should go ahead with microservices architecture. Third, we want scalable applications. Means we want to scale in future any particular feature, and if we want to scale particular feature, we need to go ahead with microservices architecture, because among 10 to 15 microservices, if we want to only scale 3 or 4 microservices, we should be able to do that, and we do not need to touch any other microservices for that. We just need to develop and scale particular microservices that are needed for our business. Fourth requirement should be when you want faster development with small teams. You have small team but you want to develop it independently and without any overhead between communicating with each other, and you do not need anyone's approval for doing work, and you do not want to lose your energy in coordinating with different team members. Then microservices architecture is really good to go ahead with. And last but not the least, very important point is that when should you go for microservices architecture? When you have a lot of resources, you are ready to manage the complexity behind microservices, then you, and only then, and if your application is requiring such kind of functionality, then you should go ahead with microservices architecture. Thank you guys for your patience, and we will discuss another features related to framework and Spring Boot related frameworks. Each and every feature will be discussed in detail in next video. Thank you.